ladies and gentlemen, so today we're going to now talk about something called a residual. And what a residual does, well, first of all, what it is it's the difference between the y value from the data and the predicted y value from the linear regression equation. And what it does is it's used to determine if we picked the right equation, type of equation. Correct type of equation. Because sometimes when we look at it, we think, oh, it looks like it could be a linear relationship. And this is really when you're kind of just given a table of values, not necessarily the graph of the table of values. And then sometimes we're like, oh, I guess maybe it wasn't a linear. So you can do this thing with residuals. And this is all your calculator information, which we will go over in class. But for now, I want you to kind of try to follow along with what I'm doing. And you can always pause the video, go back, and take a look at how to put things into your calculator. So just to give you an idea of what this is going to look like. So here would be my line of best fit in red. Again, another name for line of best fit is a linear regression. So, and what it's showing you is if the line is saying the point should be here, but it should be here, but it's really up above the line, then that's a positive residual. And if the graph is saying it should be here, and it's actually down here, then that's a negative residual. But all that's doing is it's just telling you how far apart it is. We're going to end up using in our list value, in our stat edit value thing, list 1 is going to be x, list 2 is going to be y, list 3 is going to be the residual. So it will calculate it for you. You don't have to do all of that work because, trust me, it is a lot of work. So again, this is what I just said up top. Residuals are used to tell us whether the regression was a good fit for the data. If you get no pattern in your residuals, then that means that it's a good fit. It means good equation. If you get a pattern, right here we clearly have a nice U pattern, that means that it's a bad equation. So pattern is bad. All right, so let's take a look at some examples. So here we have some data, which is talking about the latitude and the temperature in selected cities. And so we're going to put this in for X. We're going to use these for Y. So you should know how to enter those, right? Go in, if you need to pause, go in and pause it. Enter those into L1 and L2. Then it wants you to get the line of best fit. Again, that's another name for linear regression. So when I did that in the calculator, and you can check your values to see if they matched, I got A to be negative 0.983667038. B was 103.9071135. And R was negative 0.88346, 96. So my equation, because they asked me to round to the nearest hundredth, would be negative 0.98x plus 103.91. So what I'm going to do is now I'm going to go in and I'm going to follow the directions. And I'm going to go into stat edit and I'm going to turn list 3 into the residuals. And again, the directions for that are right over here. So I already did it to save us some time. But if you want to see how I did it, please pause and we will go over this in class. And I'm rounding these to the nearest whole number because they will come out as big decimals. So this was negative 9, negative 2, 16, 9, negative 6, 5, negative 15, 3, 1, negative 2. So they're kind of all over the place. And then I'm going to actually try to plot these. So if you take a look, your X values are going up by 5s, and your Y values are going up by 2s. So I just tried to do a quick little graph here to see where they're going to kind of come out. So, and then we will take a look at our next example of how we can actually take a look at it on the calculator, which is even better. So just give me a second. Okay, so as you can see then, there really is absolutely no pattern. There's not like it's, you know, making that nice U shape like in our other example. So was this a good way to model the data? Yes. There is no pattern in the residuals. Okay, now we're going to go in. We're going to try another example here. This time we're talking about a skydiver jumps from an airplane that is attached to a microcomputer recorder. So we have, this is going to be our X, this is going to be our Y, this is L1, this is L2, and then we're going to get L3. So again, put it in your calculator, pause it if you need to, but when I did that, I got Y equals AX plus B, and A was 6.035714286. B 13.07142857. This time it actually asked for R. All right, so here it looks like this R compared to the R over here. Oops, right there. The R for the second problem seems to be a stronger predictor. Right, so let's see what the residuals tell us. So when I write the equation, again, they wanted it rounded to the nearest hundredth, 6.04x plus 13.07. All right, then I went in and did the residuals. So again, we'll talk about how to do that on the calculator, but you'll hopefully be able to see. And they gave me, again, I rounded to the nearest 1 except for this value because it was only a decimal. 9, 11, 7, -1, -12. Then instead of trying to get those all on there, I just put it into the graph, which we'll talk about, but the directions are on the first page on how to see, right there, how to see the graph of the residuals. But when I sketch that out, just to give you an idea, we end up, and they do it with little boxes. You can change the symbol depending on what you would like it to be, but they showed us little boxes. So this one, right, I'm seeing a pattern, right? So that means this was not, this is a bad equation to use, type of equation to model the data. All right, so lots of calculator work. Again, if you're not bringing your calculators to class, you're really putting yourself at a disadvantage. So bring them charged, of course, so that we can make sure you understand what you're doing. Any questions, bring them with you. Try it on your calculator. Pause the video. Try it to see if you can get the same values, to see if you can get the same graph that I get. But we'll definitely go over that in class as well. Have a good night.